Okay, now I want to talk about this. Yeah, still about projectile motion. Okay, I want to talk about the time of flight. All right, let us first look at this one. For projectile returns to the same vertical level at which it was launched. That means for this type of projectile motion, this projectile motion is ejected at this angle, but then it returned to the same level. It returned to the ground, right? The ball is ejected from the ground and also returned to the ground. Okay, so for this type of projectile motion, what I want to say here is this path is symmetrical. As you can see, if we divide this into two parts, okay, divide by at the middle, the path is symmetrical. That means the left hand side path is the same as the right hand side path. Okay, so the time to go up is exactly the same time to come down. So what I want to say here is look at the vertical motion. The vertical motion is actually the free fall motion. What I want to say is about the y components. Okay, the y component is actually a free fall motion. Okay. You see? Just want to draw it out. Yeah, over here. Okay. It is a free fall motion. When ejected, throw up, okay, at initial velocity, and then until it go there, until it reach here, final velocity, yeah, the y component velocity becomes 0, and then it return down, come back down, yeah, it come back down. I just want to copy the whole thing again, yeah, and yeah, the same thing, yeah, when it coming down. Yeah, so just want to throw this off. See, let this be yeah, so this one when it come down, okay, when it coming down, here become the final velocity v. Yeah, so this projectile motion also going up and coming down. So for the vertical, the y component for this projectile motion is actually a free fall motion. It's actually a free fall motion. As you can see, this projectile motion left and right, they are symmetrical. They're symmetrical. So time to go up, time for this ball to go to this point is the same as the time to come down. That means time for the ball to come down from here to here. The time for the ball to go up from here to the maximum height is the same time as for the ball to come for the ball to come down from the top to the bottom. Okay, so the time actually is just like the free fall motion. Okay, the time to go up is the same as time to go down. The projectile motion is also the same. The time to go up is the same as the time to come down. So okay, so we can say that we can make it like this is T1 and this is T2. This is T1 and this is T2. So we can say oh, T1 is equal to T2. Okay. So the time of flight, if you want to find the time of flight the whole time, we can actually also let's make this as a small t, yeah. The time of one part as small t. We can also write this the time of flight as twice the t. You understand? Twice the t, or we can say it is T1 plus T2. Okay, because the time going up is the same as time going down. So the whole time of flight is actually 2t or T1 plus T2. Okay, it's symmetrical. Alright, as you can see, this one, the horizontal displacement is what we call horizontal range. It is the x component, Sx. and the vertical displacement is called the height. If at the maximum height, at the top point is called the maximum height. This one maximum height, we use SY. Okay. So normally when we talk about S component displacement, we say it is a range. When we talk about vertical displacement, or we can say Y component displacement, Y component displacement, it is called height. Okay, range for X, height for Y. Okay, the X displacement we use symbol R. The Y displacement we use symbol H. Because it's height and this is range. Okay. So remember, projectile motion, the Y component is actually a free fall motion. Time to go up is the same as time to go down. Time to go up is the same as time to go down. Okay, 1t, 2t. So the total time is 2t. Okay. Now let's look at this one. Maximum range. Let's say I want to throw a ball to the furthest distance. So at what angle we throw will get the maximum displacement. At what angle we throw will get the maximum displacement. Okay. When do you get the maximum displacement? So at 45 degree. The key is you throw at 45 degree. Then you will get the maximum range. We write that. That is called what we call the maximum range. Maximum, or we can say the SX is maximum. The X displacement, X component displacement is the maximum at 45 degree. That means if you throw at an angle of 45 degree, you will get the maximum range. If you less than 45, it is a shorter range. If more than 45, also you get shorter range. This is how it illustrates. 45 degree is the key to get to throw the maximum range. So if you want to kick a football, next time if you want to kick a football, you want to kick the ball at the furthest distance. Kick the ball at the furthest distance, you kick at 45 degree. Or a catapult. You launch the stone at 45 degree. Okay, that is the furthest distance. How to get the 45 degree? Actually, we use the formula. This formula, R equal to U square sine 2 theta over G. Actually, this formula is derived out of this formula. It's derived out of this. The formula over here. You have the U cos theta here. Okay, to find the SX, you just substitute into here, and then combine with the Y component, you will get the formula of, I won't show here how we derive this formula, but you can derive this formula out of the kinematic formula you learned before. So maybe this one experiment you can do by yourself, how to derive the formula for the range. Okay, a relationship between the range and the angle theta. Maybe this is one exercise on your own. But however, in our syllabus, we not really test students on how to derive this formula. Okay, we also don't use this formula also. In our syllabus, we just use this kinematic formula is enough to solve the problems in projectile motion. So for this formula, we not really test the students how to derive this formula, and we also don't use this formula to get. I just want you to let you know that the maximum range for the projectile motion, if you want to get a maximum range, you throw the ball or you kick the ball at 45 degree angle. Okay, that you will get the furthest distance. Now, all at the same speed. You kick the ball at the same speed, at any angle. Okay, if you kick the ball at the same speed at 45 degree, you get the maximum range. That's what I want to say. Now, look at this. This is one very important thing. Be careful about the vertical displacement in projectile motion. Many students always substitute the wrong value for the vertical displacement. All right. Here I want to tell you that like for this one, okay, look at the first example. Here we have several examples. The first one, the second one, and the third one. I want you to look at first look at the first example. This one, we don't really have to divide the whole motion in, although this is symmetrical path. We don't, when we want to find the time, of flight, we don't really have to find T1 and then also find T2 and then total up T1 plus T2 to get the time of flight. We don't really have to do that. Yeah, we don't really have to do that. We can straight away find the time of flight directly by substituting the y component displacement equal to 0. We substitute Sy equal to 0, we can immediately find the time already, but into this formula. We substitute the equation into this formula, Sy equal to ut plus minus half gt square. We use this formula. How to find the time of flight? Let's say I want to find the time of flight. S equal to okay, for the y components, S equal to ut plus half at square, but because the acceleration in y component is negative g, so it become a you substitute with negative g, you get negative half gt square. Okay, then because all this in the y component, we just put the subscript or the displacement is y, the velocity is y, acceleration also in y component. Okay, so we just substitute s for this, the first example. The ball returned to the same level. You see that? You look at this projectile motion, the y component. If you talk about only the y component, this projectile motion is the same as a free fall motion going up and going back to the same level. You see that? Going back to the same level. So this level where the ball is released is actually the origin. Sy is 0, is the origin. Okay, it's the origin. So when the ball goes up and goes back down to the same level, actually it returned to the origin. So the vertical displacement, the vertical displacement Sy is 0. 0. So when we talk about this projectile motion, when we only focus on the Sy, the vertical displacement, it is 0 because the Sy is actually a free fall motion. It returned to the same level. You see, it returned to the ground. The y component or the free fall motion is actually returned to the same level, returned to the origin. So Sy is 0. So when we want to find, let's say we want to find the time of flight, we want to find, what's the time of flight? The time of flight for the ball to throw up at an angle and then return to the ground. What is the total time of flight? What is the total time of flight the whole journey before reaching ground? What is the time of flight for the whole journey before reaching the ground? What is the total time of flight? How to find the total time of flight? The total time of flight for this projectile motion is the same as the time for the free fall motion. The time, we can say this is the time for y component. This time of the projectile motion is the same as the time of the y component. I did tell you before about this. The time for the s component is equal to the time of y component is also equal to the time of the projectile motion. It's also equal to the time of projectile motion. I did tell you about this. I told you several times already. Time of projectile motion, the total time for the projectile motion is the same as the time of the y component and also the same as the time of x component. I also show you the animation about the projectile motion, yeah, which I created myself to show you that the time of projectile is the same as the time of the free fall. Okay, so what I want to say is the time of flight of this projectile is the same as the time of the free fall motion. If we want to find the time of flight, we just refer to the free fall motion. Okay, we just refer to the y component, which is a free fall motion. So for free fall motion, it seems that the y displacement is 0 because it returned to the origin. So from here we can find the time of the free fall motion where it returned to the origin. So how to find the time of the free fall? We substitute the y displacement equal to 0 because the ball returned to the origin, returned to the same level. We just substitute sy. We just substitute sy equal to 0. Substitute sy equal to 0, and then we substitute the value of uy. Last time you also learned about the uy. How to find the uy? Uy, you have the you just uy equal to u sine theta. Substitute u sine theta. U is the u sine theta. Yeah. And then negative half gt square. G is value what? G is value. G is positive value. Because the negative is already for the acceleration only. G itself is positive value. You just substitute G equal to 9.81. Then you can find the time of flight. So from here you can get the Ty equal to what value? Understand or not? You can get the time of the free fall motion, and the time of the free fall motion is the same as the time of the projectile motion. So the time of flight, the time of the free fall motion is the same as the time of the projectile. Because I told you already, projectile motion is a combination of free fall and a constant velocity in x component. So they all happen simultaneously. Meaning that, what it means by simultaneously? They have the same time. They begin together, they end together. Yeah? They begin together and end together. So we can get the time of the whole flight, the time of projectile motion, by just referring to the y component, by just referring to the free fall motion. Understand or not? So once you get the time of the free fall motion, you can get the time of projectile. Okay, that's mine. So you just substitute sy equal to 0 for the first case. Yeah, for this first case. So how about the if the ball return to the same level, the vertical displacement is 0. It's just that the free fall return to the same origin, same level. So how about the second example? This one sy is 0, but sx for the horizontal displacement is not 0. Sx you maybe have certain value. Maybe it can be a 20 meter. For example, sx is not 0, but sy is 0. Okay. So now, for the second example, this one is ball goes up and hit a building. Maybe this is like a basketball, the throw up and then fall into a net. Yeah, maybe this is like a basketball. Yeah. Like for this case, the ball didn't return to the ground. It didn't return to the ground. It goes up to the net or goes up to the building. This one, the y displacement is positive. The y displacement is positive. Yeah, sy is positive. How to get the, how to get, actually, what is mean by displacement again? What is mean by displacement? Displacement, okay, talking about distance and displacement. Talking about distance and displacement, I hope you are already clear. Distance is the total path taken. Total path taken. Displacement is the shortest distance or shortcut between initial and final point. Shortest distance. Last time, what is the initial point? Like last time, what is the initial point? Initial point is the origin. The final point also origin. The initial point of origin, initial point is origin, final point is also origin. So that means the initial and final point also at the origin at the same point. That's why sy equal to 0. Sy equal to 0 because it's about displacement. It's about displacement. It's not about distance. Distance, you need to go up and go down, plus together. That's the total path. But talking about displacement, we don't consider the path taken. We don't consider the path taken. We only consider the initial and final point. In this case, the initial and final point at the same point. So the shortest distance between them, there's no distance between them because they're at the same point. So the displacement is 0. Okay. Don't go to total up, going up, going down. No, that's for distance. We are not talking about distance. Sy is for displacement, not distance. Okay. We only consider the initial and final point. Now, talking about the second example, this one, the initial point is here. The final point is here. So, what's the shortest distance? The shortest distance is taking from the initial, taking from the initial point, up to the final point. This is the shortest distance. This is Sy. Do you see that? This is Sy. So Sy, the Sy is positive. Why is it positive? Sy. Why is it Sy positive? Again, Sy displacement. How to get positive? If the object is above origin. Object is above origin, then displacement is positive. If displacement is negative, means it's below origin. So look at this example again. The final point is above the origin. This is the here is the origin. Here is the origin or the initial point. So now the final point is above origin. Above origin, that's why displacement positive. Okay. So this is Sy positive. How about here? Look at this one. This one throws up, but then it returns to the same level and then goes further down. For this case, what's the y component? Displacement. Remember again, this displacement is about shortest distance between initial and final point. So where's the final point now? Okay, this is actually the same like the balls, the balls for the y component. For the y component, is like going up and then going down, coming here. So this is the, this is the initial point, and this is the final point. Okay. Maybe right over here. Here over here. So this is the this is the initial point, initial level, and this is the final level. So what's the vertical displacement? What's the vertical displacement? Do we consider this part? No. If we consider the whole path going up and going down, that's the total path taken. That's the total path. That's distance, not displacement. So when talking about vertical displacement, we don't consider this part. We don't consider this part. We only consider between initial level and final level. Initial level and final level. So we only take the displacement going from initial to final, the shortest distance between initial and final. So which is this part over here. This is the vertical displacement, and it is positive or negative? Positive or negative? Remember again what I tell you? Displacement is negative if the final point, if the object or the final point is below the origin, below the initial. If the final point is below the initial, or object is below the origin, the displacement is negative. Go back to this one. So this object now is below the origin, below the initial point. This is the origin here. Okay. the origin here. So the ball is below origin. So that's why this S is negative. You get a negative displacement. So remember, SY is only not taking this part is not in consideration. We only take the initial level and final level, the shortest distance between initial and final point. This part only. Only take this part. Then we can find we substitute this SY into this equation, SY, then we can find the time of flight, which is also equal to the time of projectile motion. Okay, I hope you are clear. For this one is maybe I draw over here. This one is we take let's say for this ball going up and going down, hit here. So what is the SY? What is the SY? This is the initial point or the origin. It is origin here, and this is the final point. So this one is the SY is where? SY is this one. This is the SY. Okay. For this part, still go up some more and come down. This part not in the SY. This part not in the SY. SY only take the shortest distance between initial level and final level. Okay, this is the SY. And this SY is positive or negative. Why this SY is positive or negative? Because the object now is above the origin. Remember? It is the object is above origin. Then S is positive. Because this displacement this object is above the origin. So that's why this SY is positive. Okay. So these are the 4 examples. Okay. So this SY is 0. This SY is positive. This SY is negative. Okay. And we only consider initial and the shortest distance between initial and final point. Okay. That's all for this part. Okay. Now goes to the next video.